Mike's done a sketch model in polygons for this charging station for the electric car, and I'm going to use it as an example of more of a product-like design. And also it's simple enough that we can get a finished model that we can prepare for output to production. So I'll use his polygon model as a reference and build a proper NURBS model on top. And I've started by using a scaled cube for 1/4 of the base, with this raised platform for the columns. And I've removed these inner surfaces as I'll be mirroring it to create the 4 parts. So now I'm going to do some modelling, and I'll redesign this skin here as a blended surface, and I'll add the fillets. But the most important thing to do before I start is to open the construction options, and in the tolerances continuity area, set the maximum gap distance or position continuity. And this is at 0.01 at the moment because we've been using the general CAD settings preset, which is reasonable for a car exterior. But for product design, typically it'll require a smaller gap between the edges. So if you know which CAD system you'll be exporting to, you can choose that preset. Or if you have company standards or your own preferences, then you can set that yourself in the user-defined setting. But I'm going to use these 2 CATIA presets only because V4 is set to 0.01 and V5 is set 10 times smaller at 0.001, and I can use those 2 to explain the looser and tighter tolerances. So I'll start with V4 and I'll set it before I start to model. And now when I use a surface tool, it refers to that tolerance value to decide how accurately to build itself, so how closely surface edges are built to each other. So with the round, I'm just going to put a 0 value on these base edges to help with the trimming. And you might notice this hexagon symbol, and that's a thing called a setback corner, which doesn't give us a good result in this case. So I can just click on the symbol and rebuild it to get a normal fillet. Or if I prefer, I can set that up in the round tool control window beforehand. So for this raised area, I want to make it work quite hard, so I'll do a freeform blend with curvature on both sides. And this will also refer to that gap tolerance to decide how accurately it needs to match the edges. Now I'll just turn off the polygons, and that looks fine, but any gaps would only be on a microscopic level anyway, so we need a tool to check it more closely. So I can use the surface continuity check set to position and pick individual edges, and this will check against that construction setting of 0.01 mm. But the disadvantage is that I have to pick each edge. So I've got another tool that I can use on the Surface Edit palette, which is Stitch. And that lets me pick my surfaces and sews them together into a new single entity called a shell. And that shell checks for a watertight surface. So where it's shown orange, the surfaces are connected within tolerance. And where it's yellow, it's either an open edge like here, or a gap. Now I can simulate some typical problems by tightening up the tolerances that I'm checking to. So if I go to CATIA V5, that's 0.001 now. And then if I do the same thing again, just stitch the surfaces, let's see what we get. So if I move this across, you can see that it's showing some yellow edges, which are gaps. So these long ones here are mostly yellow, and there's a little problem here as well. So the stitch is a quick way to highlight the tolerance problems. But if I want more information, I can use the surface continuity check again. And that confirms there's a problem with the yellow locator. And my middle mouse button shows where it is, and the right mouse button tells me how much. So 0.0039. And 0.03 is bigger than 0.001, which is why it's failed at these tolerances, but it's smaller than 0.01, which is why it succeeded at the CATIA V4 tolerances. So if I want a surface to stitch at a tight tolerance, then I need to build it to that tight tolerance. So I can get rid of that one, and I'll need to undo the round, and then build it again. And I'm just going to keep this blend surface and move it over here so that we can use it for comparison later on. So now that I've got the tighter tolerances set, I can build the round again. And this time it'll be referring to that tighter tolerance of 0.001 as it builds each surface. And you'll notice this time it's defaulted to the corner style that I wanted. And then watch what happens when I build the freeform blend with exactly the same settings. It takes a little bit longer to build, and it's created 92 spans, whereas when I built it at the looser tolerances, it only created 28 spans. So that's the only disadvantage of working to tighter tolerances. So if you're only doing sketch modelling, you might choose to stick with the looser settings to keep your surfaces lighter. So let's now check this at the tighter tolerances, and we'd expect it to be okay. So I'll stitch those surfaces, and then move the stitch shell off to the side. And you can see that the round surfaces are fine, but it's indicating a problem here. And this is something you've got to be careful of, because the stitch tool is great for quickly checking the whole model. But you need to double check with the surface continuity checker. And if I click on this edge, it's telling me that the whole edge is within tolerance. And it's the same at the top. So in this case, I'll ignore the yellow edge on the stitch surfaces and I'll trust the surface continuity check. And this will give me the confidence that these surfaces are going to export successfully as a watertight model to CATIA V5. And in fact, it'll be accurate enough for most downstream CAD systems. So if I want to complete the model of the base, I just need to mirror my 4/4 and then do a final check that the 4 segments will stitch together. And I just need to ignore these yellow edges because I've already established that they're okay. So we'll continue working with stitching in more detail after we've built the main body of the charging station.